There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, red, and zinc, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hi, everybody. Today we're going to talk about polymers. And this is a model of polyethylene. It's a bunch of carbon atoms joined together in a chain. And the particular polymer that I'm going to talk about is something called polystyrene. And polystyrene has every one of these hydrogens replaced by a benzene ring. And we have two examples of polystyrene. One is this salt shaker. The clear part of this is polystyrene.
Which we're not going to dissolve.
Which we're not going to dissolve. And the other one is a cup. And you can tell what polymer it is by just looking underneath at the code. And number 6 on the recycling code is PS, which is polystyrene. Now, obviously, this will not soften or dissolve in water because it's used to hold water, hot water or cold water or hot drink, which is mostly water,
yeah,
a cold drink.
Yeah, if it dissolved in water, then you pour water into it, and then all of a sudden the cup, and all of a sudden you don't have a cup.
Now, I'm using a chemical called acetone, and acetone is able to soften this. And, you know, just like the Wicked Witch, when they poured water on her, she got to get soft and kind of became a blob.
She dissolved.
All right, so we're going to take some. This is a dangerous chemical, so you don't want to breathe too much of it. I'm going to pour just about 50 milliliters in the bottom of this container and put the top on. Now listen, I haven't tried this in a long time, and it's from memory that I thought it dissolves, but let's see what happens.
It's a turn into a gum, but it's not a gum that you would want to chew.
Right.
Don't chew this at home.
All right, are you ready, everyone? All right, let's see what happens. Okay, I hear a fuzzy sound. You can see that it's kind of wiggling around.
I can see that.
You can see that it's getting smaller and smaller.
Hold on, I'm going to see. Let's see if we can zoom in.
It's all kind of gooey at the bottom as I look here. It's the incredible shrinking cup. It's not really dissolving, but it's softening to the extent that it no longer has a rigid structure. And I'm not touching it, it's just doing this on its own. I'll just give it a little swirl. It's kind of cool, I think. It's very cool. Now, acetone is different than water. It has a different freezing point. It has a different melting point. It's an organic solvent. And I got this at Ace Hardware. But it's one you must be careful. It's flammable. If you light a match to it, it will burn. And it's not something you definitely wouldn't want to drink it. You'd be dead in a minute.
Oh, let's look through the cup. So can you take the cup out?
Well, I can sort of take the cup out.
Wait. See?
The cup is getting smaller and smaller, and it's becoming a worthless cup.
It already is a worthless cup.
So this is kind of a, I would say for young people, don't try this at home, but it's kind of a neat little demonstration of what happens to polystyrene when you put it in acetone. It's not soluble in water, but it kind of dissolves. It really dissolves in acetone. Now, this thing is kind of sticking to the side, so let me take it out and put it in sideways so that it'll dissolve that way.
Oh, it's
Okay.
so
It's very volatile. When you touch it with your hand, you can feel. Try not to breathe it, though. Try not to. All right, I'm going to put this out. You can see that there actually is some residue left over, a cookie residue. So it doesn't really dissolve. Some of it dissolves, but it won't dissolve completely. But it's certainly different than it was. Okay, so again, I'll show you a model using Spartan of what it looks like on the TV screen.
Let's stop this recording and then go to.
All right. Well, I'm going to show you using Spartan how to make polyethylene. I'm going to make a chain of carbon atoms. That would be polyethylene. A bunch of carbon atoms with 4 bonds to each and then hydrogens attached to them. Polyethylene. But now I'm going to add benzene rings. Okay, every other one. Benzene. I'm going to put them kind of zigzagging. Benzene. Skip one. Put one. Skip one. Put one. Skip one. Put one. Skip one. Put one. Skip one. Okay, and now let's just close it up. And that's polyethylene. It probably would be a little more random than this, but that's what polystyrene, I'm sorry, polystyrene looks like, roughly. And in the polystyrene that I use, the polystyrene cup that you're all styrofoam or same thing, you're all familiar with. There's a lot of air bubbles, so it's very light, and it's a good insulator. So it keeps your coffee hot, or if you're using a cold drink, it keeps it cold. It keeps heat from flowing in or flowing out. Remember, heat always flows from hotter to colder. So if your coffee's hot, it will flow out of the cup, and the styrofoam protects the cup. So thank you for your attention, and we'll see you next time.